So next we want to get the coordinates of where we want to sample from our sprites target, the reflection texture that has all the sprites in it. So that's the texture that we want to reflect onto the crystals. So for now, that'll just be our player because we haven't added the monsters yet. So let's get the coordinates, and we'll call that reflect UV. So the x-coordinate would be the current screen position, dot x, divided by the screen's width, the target resolution's width, and we're going to say times scale, which will be an optional parameter we haven't added yet. So let's go ahead and add that, and we'll make it constant. We'll put it out here. First we'll pass in the screen parameter. We'll have to add that to our C# code. And we're just going to put some constants out here. As soon as we open this, we can see them right away and adjust them if we want to. 0.7879 maybe. So 79% scale. I added this comment here. It might seem a bit confusing. The closer to 0 we get, the bigger it gets. Closer to 1 we get, the smaller it gets. And that's because of how we're extracting it. So this is like inverse scale. A little confusing. So instead of this, just imagine that I had this as 0.4 in the first loop, or for the first pixel. And just for argument's sake, let's say the next one's going to be 0.5. That's a difference of 0.1 between those two pixels where it's going to be sampling from. So if we want to make the image bigger, then we'd want to sample those pixels closer together. So we'd actually want this distance to become smaller. So that's why we're scaling it sort of backwards. And if we wanted the image to be smaller, we'd want the distance between each pixel to be bigger. So that's the reason why it's backwards and inside out. And we're going to sample from over to the right a little bit. That means the sample source is always going to be a little bit ahead of where the pixel is that we're trying to draw. So that way, how do I explain that? And this, of course, assumes a certain screen size. So this is actually 50 pixels to the right. So that would be like doing this. But I'm just hard coding it. Oh, I just noticed there's a bug here. Go up to norm UV, change this to .x. So we're just moving horizontally to the right, 128 pixels. For a reflection UV coordinate, we can copy the x coordinate, change it to y, and we'll do the same thing. And like I said, this number assumes that your screen resolution isn't going to change. And if you're using a different resolution, then you calculate that number a little differently. The display resolution can change dynamically, but the target resolution is always going to be a standard resolution for the game. So that's why I can get away with doing stuff like this. So now we need to distort where we sample from. So we'll need a distortion amount that we'll have to calculate. Distort. And we can collect that from our UV map. So texture 2D, we'll get the pixel off of the normal map, which is at our normal UV coordinate we calculated. And it could be XY, ZW, but we're just getting XY because that's the R and G value, which is red and green. Going to multiply it by 2 and subtract 1 so that it scales from -1 to +1 in the distortion amounts. And then we need a distortion scale, how much it distorts. We'll call it distort amount. So, well, this is technically the distort amount. This is like the scale of the distortion, but you get the picture. So we'll say distort amount 0.007, so roughly somewhere between 6 to 10 pixels of distortion scaling. So I'll just say maybe 0.001, 0.04, which would be like 40 pixels approximately. Since we're scaling it, it might be slightly different than that. So for example, if your red value was 0, this would become -1, and then it would be -1 times this. 1 pixel is like 0.001, so that'd be like -7 pixels, and that would become the x value for the distortion. We could go with the green value, for example. If the green value was 0.9, or became 0.9 after doing the times 2 minus 1, because it would be either -1 or -1 to +1, then it would be slightly less than 0.7 or 7 pixels to the right. So that's kind of how that works. Or actually, no, that would be 7 pixels down, or 7 pixels in the y direction for the distortion amount. Sorry, I should say for the distortion, because distortion amount is now sort of the scale of the distortion. So. And let's get the float4 text color. which is the color of pixel to draw from the crystals. And initially, we'll get that color of the pixel on the crystals that's there. I'm just going to add some comments real quick. So we have our UV coordinate of what we want to reflect calculated off of the sprite image, and we'd like to distort it before we put it over top of our colored pixel for our crystal. To distort it, we'll just add in the distortion. So take our UV coordinate, add in the distortion given to us from the red and green values, which are kind of indicating the slope and thus providing a distortion amount in those directions. So then we can go ahead and get the actual color to reflect using that coordinate, using reflect samp, the reflect coordinate, UV, alien, hero, or other sprites, pixel to reflect. So that would actually be any of the sprites pixels to reflect. In game 1, let's go down to the section where there's render targets, and just after that we'll add our effects stuff in there. So we'll say effects section, we'll say effect crystal effects. We'll go down into load content to where we said we were going to put our effects stuff in. Right after set image tiles, we'll put crystal effects equals content.load. We're going to load an effect crystal because that's what we named the file. And we'll pass in parameters that you can pass in early on. They aren't going to change. The screen or target dimensions, set value, to screen width and screen height. Since our crystals are rendered differently, we'll set them up as a type of process tile so that they can be provided with different effects. Let's copy this in map and we'll call it crystals. While we're at it, let's add a dynamic variable crystal color so the colors can kind of pulsate for the crystals, and we can control that in the update. And we'll want to keep track how many crystals we got, so we'll put crystal count there. There, I added in some comments too. And we're going to need timer too for the timing of the crystal animation. So I have this labeled as map data, so map related stuff. And this is just kind of whatever. As your code gets a little more complicated, you might want to organize it using regions or stuff like that. Let's go down into the map constructor, and we can copy this line here for overlap tiles. Just change it to crystals. And 250 should be fine. That's how many can be on screen at once. We'll prepare memory for those just in case. So in here, in update vars for map, we'll update the crystal colors. Timer plus equals 0.05f double t equals double timer. That way we don't have to do a bunch of casting. So to get the crystal color, say new color, and we could just have the values bounce back and forth, but I'm going to use sine wave to sort of adjust the red, green, blue values for the color. So convert to float, math, sine, timer. We'll say 20% size, sine wave plus 0.8f. So the top 20% of the red value is going to wave up and down. Sine timer plus half. This just offsets the timer value so that it's not the same. So it's kind of going at a different frequency, or what's the word? So that the waves aren't coherent. So times 0. So that they're different timing. So 20% again, 0.8f. Time plus 1 so that it's really offset. The return value of that sine wave is always going to be within the same range. It's kind of normalized, so that'll be a 20% also, plus 0.8f. And the reason I varied these is that as one goes up, the other one isn't also going up at the same rate. They're all kind of on their own part of that sine wave. You could vary these scaling values too. So like if this is 0.3, you'd make this 0.7. It's got to add up to 1. If we go into draw tiles and go down to where we got overlap count reset to 0, we're also going to reset our crystal count, and it'll work in pretty much the same way. And if we go down to where it says actual tile images are drawn, store overlaps, if tiles ab.overlap, we're going to do a similar thing for crystals. We'll say else if the tiles type is tile type reflector crystal count dot add. Give it the tile position. It also wants the source rectangle, which would be the sheet rect. So we've got sh right here, and tiles A, B, the rotation, and the scale. So now it has all the information it needs to render afterward when we've set up a different effect. So this is what it's doing. Adds the crystal, increments the counter. I suppose we could have it directly increment or use a list, but this works. So where it says draw overlaps, let's just copy the concept here, and we'll just paste in here, change it to crystals. So this will become draw crystals, and we're going to use crystal count. And they're on the tiles image, so I'm just going to change this to crystals. Double click this, paste, and this will be crystal color, which we're dynamically updating. Crystal's rotation, origin, and crystal scale. That should do it. So in game one, in the draw section, before showing the sprites and after drawing the tiles, we're going to draw the crystals in using a different effect. First, we'll set a crystal effect parameter for the reflection map. Parameters passing to the texture reflect map. Set value, setting the texture as the sprite target. So that's what we want to reflect. And we'll say sprite batch dot begin. We're going to be setting the crystal effects in the sprite batch call. Sprite mode, sprite sort mode, deferred, done state, alpha, sampler state, linear clamp, depth stencil state, none, rasterizer state, don't need to call anything. Crystal effects, that's the key point there. Then we'll say map.drawCrystals and spritebatch.end because we're no longer using the crystal effect. Oh yeah, we mustn't forget to go into the monogame pipeline tool and add our new effect, crystal.effects. And then we can build that. Something is wrong with it. We'll have to check it. It said line 17, unexpected F, should be semicolon. I don't have line numbers turned on, but that would be around here. So it's seeing this. Oh, there's a semicolon missing at the end of that. That's a pretty common mistake, actually. Another mistake I noticed is I wanted to call this text samp rather than text sampler, because that's what I was using down here. Text samp. It's just a little shorter. Oh yeah, and we're not actually quite done with our pixel shader here. We're going to need to mix our reflection color with the color of the crystal, and let's make a constant for the amount that we want to mix them together. So that amount will be the visibility of the reflection. So we'll just call it visibility, 70%. Don't need the F in this. Now this is totally wrong. So we'll say if the texture color alpha is over a desired threshold, which we're going to say 50% visible. So it's got to be a fairly visible pixel before we'll even bother with it. We don't want to draw outside the crystal. That wouldn't make any sense. So, and if the reflection alpha is greater than 0.9, then what we'll do is we'll mix in the reflection into the texture color. So we'll say text color, which we already have here, and we're going to modify it. It's going to be reflect. Of course, we're only going to modify it for when the reflection is actually on it. So it's going to be a reflection times how visible that reflection is, the visibility, plus the text color. So one might be 20%, one might be 80%, one could be 70, the other one could be 30, and we'll say times 1 minus visibility to get the other portion of that percentage. The two have to add up to 100%. So return the text color times the colorization for the crystal, which is passed in through here, which is passed in from the vertex shader. Oh, we got a bug in here. It said line 38. Too many brackets. So the distortions look pretty good. And if we wanted to go really crazy with our normal maps, we could also take into account the distance from the center of the screen to the pixel and figure out the angular distance between what that vector would be in an imaginary world, and use that to set your distortion mounts and even to set lighting. Or you could just do some cool colorization effects so that it sparkles a different color as you pass by it. A fairly simple way to get sort of a sparkling effect is to sample from something that you can sort of use like an environmental map to sort of create the sparkles, and then just distort those sample sources over the image as you mix in the color. So we're going to do that. So I'll add a texture here. Let's copy this one, we'll just pass in our background, and we'll use that as a sample source for creating the sort of distorted sparkly reflections. Call it backsamp, and we'll say it's environment map to refract. We'll call it background. It is the background, essentially. Background to refract. And we can't use the S1 register, so we'll have to change that to S2 because it's already being used. And pass it in as backmap. And this one, we'll use wrapping for the UV sampling. Since our reflection UV coordinate for the sprites is from a map that's the same size, we can take advantage of that and piggyback off of it to sample from the background image. So we'll say float, or we'll call it sparkle. We'll sample from the background image that we pass in, which is going to be our stars. Reflect UV, and we're going to distort it with a little more extreme distortion, so it's kind of sparkling. So add in the distortion amount to offset the UV coordinate, and we'll distort it a lot more. So if it's 7 pixels, this one's going to be 42. So really distorted, so you get that really kind of shimmery effect as it goes over the surface of the crystal. So what we'll do is, if the texture color is something we care about, if the alpha is greater than 0.5, then there's something there, so we want to add that sparkle into it. So we'll say text color plus equals the sparkle. So that additive blends that color in with the color that's on the crystal. Now this kind of remakes the color, so we'll have to factor that in here too. So right here we'll just put plus sparkle, because it's actually going to be reflecting this and rebuilding the color from scratch. And this texture doesn't have to be background. You can use any kind of texture that you feel would be effective, sort of an environmental texture or something with lots of white in it that you can make sparkle across the surface. Well, you'd want it to have lots of black in it too, so it doesn't sparkle too much. Keep in mind too, you may need to play around with these adjustment values here to kind of offset your sprites so that it's either sampling so that they're further to the right or further up in the reflection. So you may have to play with those values. If you wanted to, you could make those values relative to the center of the screen so that it actually pans across the image from left to right. And what I mean by that is, like, you'll see the crystal on the right side, and as you get closer to it, you'll see the reflection appear over top of it. And as it goes past you, the positioning of the reflection relative to the crystal will change based on the angle. So the difference between the center of the screen and where the pixels are that it's going to be drawing. And it'll use that to figure out the offset of that image. But that's not really necessary. So we have this backsamp or backmap texture that we need to pass in. So we'll go down to our load content in game 1, and in the effects section, say crystal effects parameters. This time passing in backmap. So we can do this ahead of time because it never changes. There. And as you can see, we've got the sparkles on the crystals now. Looks a lot better.